This tutorial will show how to install and use the UEFI shell. I will assume some prior experience with Linux and a shell language like Bash, as well as the general idea of what a bootloader does. Before I talk about the UEFI shell, I'll explain the difference between the BIOS and UEFI. You should be familiar with the BIOS from your OS class. It's a very simple pre-OS environment that starts executing the bootloader. However, BIOS is very outdated and it was created in 1975 and still uses 16-bit mode. The modern alternative, and what you probably have installed on all of your devices, is the Unified Extensible Firmware Interface, or UEFI. UEFI is a very complex boot environment supporting advanced graphics, arbitrary drivers, security features, and 64-bit mode. To make it clear, the actual UEFI code exists in a separate non-volatile RAM chip on the motherboard shown on the left. Usually, most people never interact inside the UEFI environment. If they do, it'll be in a GUI like the one shown on the right. But the UEFI shell offers a more powerful and non-platform specific way to interact with the UEFI environment. The reason this can't be done from a regular shell is that after running the OS bootloader, code no longer runs in the UEFI environment. While in UEFI land, applications can make calls to boot services, a table of pointers to useful functions. However, after calling one of those functions called exit boot services, the boot service table is destroyed. Usually, UEFI applications are bootloaders that make this call. However, not all UEFI applications need to. The UEFI shell is one example. This means that the UEFI shell is completely independent of an operating system or even a bootloader. As the name of UEFI implies, the entire UEFI environment is very extensible. For example, we can load arbitrary file system drivers so that any UEFI application, including the UEFI shell, can interact with the root partition of the OS. The most common use cases are for debugging boot issues and testing out UEFI applications during development. To showcase the UEFI shell, I'll be running an Ubuntu VM with UEFI, Secure Boot, and TPM support. I won't go in depth over these commands, but they are here if you wish to follow along. More information is in the references. Next is the installation guide. Your package manager of choice will likely have a UEFI shell package, UEFI shell x64 for apt or EDK2 shell for pacman. Just copy the shell binary to the UEFI partition, which in most distributions will be mounted to /boot or /boot/UEFI. Finally, we need to create a boot entry. This can be done from within the UEFI GUI, but since the GUI isn't standardized, it may be safer and easier to use a tool like UEFI Boot Manager as shown on the slide. A few notes on the installation. This will not work with Secure Boot enabled. The process for Secure Boot is too complicated for this tutorial, and the process also varies by OS and firmware. Additionally, manually copying the UEFI shell binary isn't recommended. You'll want to add upgrade hooks to automatically place the shell in the UEFI partition for you. Here's some useful UEFI shell commands. All of the standard file system commands exist like ls and cd. bcfg is the most useful command. This is a one-stop shop for all boot entry and driver management. I'll now move on to a live demo to show these commands in action. Here I have a fresh Ubuntu VM. I just ran the commands to install the UEFI shell, and if I reboot, I'll be dropped into the UEFI shell. First thing you'll notice is the file system mappings. If I ignore these and try doing an ls, nothing will happen. This is because I need to tell the UEFI shell which file system I want to look in. In this case, only FS0 exists, which is the FAT32 UEFI partition. Now if I do an ls, you'll be able to see the files. As mentioned earlier, bcfg is very useful. For example, to see all the boot entries, I can do bcfg boot dump, and you can see information about all the boot entries, including the UEFI shell entry at the top. To see the help page, you can do help bcfg, and if you want to give it paging mode, you can do help bcfg-b, in which case press enter to continue. One last thing I'll show is the UEFI driver. I've already installed an UEFI ext4 driver, which I can load with the load command. So load ext4, and now if I update the file system mapping with map-r, you can see one of those block devices turn into FS1. If I go into that and do an ls, I can now see the files of my Ubuntu machine, which is very useful for any sort of error recovery. To summarize, UEFI is a modern pre-boot environment meant to replace BIOS, and the UEFI shell provides a way to interact with UEFI through a familiar shell syntax. There's much more functionality that I didn't have time to cover. For example, you can do basic scripting, get the UEFI shell working with Secure Boot enabled, set up automated upgrade hooks, and more. Finally, here are my references.